Hello everyone. Let's go ahead and talk about section 7.4, formal charges and resonance. We will be splitting this into a couple of videos. In this first video, we will discuss formal charges. So the learning objectives for this video: compute formal charges for atoms in any Lewis structure, and use formal charges to identify the most reasonable Lewis structure for a given molecule. After the previous sections, you should feel comfortable with drawing a correct Lewis structure. If you are not comfortable with that, please go back and review that material and get some practice with that before watching this video. One of the things that will sometimes happen is that we can have more than one way of having a satisfactory Lewis structure. So to be satisfactory, the Lewis structure would need to have each atom in the Lewis structure would have satisfied the octet rule, and the total number of valence electrons in the molecule be the same as the number of electrons in the individual atoms. So to this point, we've said if you can do that, then you have an okay Lewis structure. However, there are times when you could have potentially more than one Lewis structure that would be valid by following those rules. So we want to have some additional guidelines for some of those, I guess you could call them edge cases, where something doesn't, you have more than one option and you have to decide on which one is the most appropriate. So how we do that is with the concept of the formal charge. To start with, you need to understand that this is a hypothetical thing. This is not a charge the way a cation or anion would have a charge. It's a way of looking at things to have a better understanding of what makes the most sense. So how we decide on the formal charge is we look at each of the atoms within the proposed Lewis structure, and we do this following calculation. So we look at the free atom and what would the number of valence shell electrons be in that free atom. So this is, again, similar to when you do the initial decision with a Lewis dot structure. From that, we subtract the number of lone pairs of electrons that are on that atom within the proposed Lewis structure, and then we subtract half of the number of bonding electrons that are on that electron, or I'm sorry, that are on that atom. So number of initial electrons from the Lewis dot structure minus the number of lone pair electrons minus half of the number of bonding electrons. So this is how we would calculate the formal charge. You would do this for each of the atoms within the Lewis structure, and then the total of the formal charges of all of that should add up to the charge on the structure itself. So if you have a neutral atom, they should all add up to 0. If you have an ion, they should add up to the charge of the ion. Okay, so let's look at an example. We are given this structure here, and I'm going to start with the structure itself as opposed to having you, first come up with the Lewis structure from the formula. So you're provided with the structure, and let's go from there. We notice that the structure itself does have a negative charge. So what we do, we notice that we have one central atom and we have 4 terminal atoms. The terminal atoms are all the same. So although we have 5 separate atoms here, 4 of them are identical to each other, and so we will basically be assigning 2 formal charges here. So for the iodine, we have, for any halogen, we have 7 valence electrons in the initial dot structure. And then, unfortunately, your book could be a little bit more clear in where this number 8 is coming from. But where it's coming from is the same thing as we talked about in this formula: number of lone pairs minus half of the bonding electrons. So here we have 1, 2, 3, 4 lone pairs, and then we have 1, 2, 3, 4 bonding electrons, because we're counting each one of these bonds has 2 electrons, so we're counting half of them. So 4 plus 4 is 8. So that's how we got the 8 here, is that is the number of electrons assigned to the iodine in this structure. So we have 7 minus 8 gives us a formal charge of a minus 1. For the chlorines, each of the chlorines has, again, halogen start with 7. And then within the structure itself, we have 2, 4, 6 from the lone pairs, and then 1 from the single bond. So we have 7 in terms of the number of things within the molecule itself. So we have 7 minus 7 equals 0. So the formal charge for each of the chlorines would be 0. So we have a minus 1. We have 4 zeros. We add all of that together. That adds up to a minus 1. The overall structure has a charge of a minus 1. So the formal charge, the sum of the formal charges is adding up to the charge of the whole thing. So we know that we're on the right track there. Okay, so we want to double check at the end that they do add up in that way. There's another example here if you would like to check that as well. And then another example. So a couple of examples you can kind of look at on your own if you want a bit more practice with that. So we can use the concept of formal charge to predict the correct molecular structure. So how this works is if you have been provided with two potential Lewis structures for a molecule, we can look at formal charges to decide which of them is the most reasonable. So these are the things to consider here. So if you are able to come up with a structure with all of the formal charges equal to 0, that is preferable to one in which they are not 0. With the example we just looked at, of course, we're not able to do that because you have to have some kind of a negative charge to end up with a negative charge at the end. So if you can get all zeros, that would be the best. In the case we just looked at, we had a Lewis structure that must have a non-zero formal charge because overall the structure does have a charge. So the arrangement with the smallest non-zero formal charge is preferable. And so that's what we did. We had something with only one minus 1 charge, and the overall thing was a minus 1. So that was, we only had one place where we had a non-zero charge. And then Lewis structures are preferable when adjacent formal charges are 0 or of the opposite sign. So within the structure itself, if you have the option of putting, say, a negative formal charge on an atom next to another atom with a negative charge, that is not preferable. You would prefer to have a negative next to a positive. And if you have several possibilities with the same distribution, so if you have several things where you have to have a minus 1 charge somewhere, you want that negative charge to be on the more electronegative atom, typically, would be the case. So those are some guidelines for deciding amongst possible options as to which one is the best. So let's look at an example of using this. So here we're looking at carbon dioxide, and we are showing a couple of different possible Lewis structures for carbon dioxide. All of these are going to satisfy the octet rule, and they all have the correct number of electrons. So the guidelines we use in section 7.3 would have been okay for these for the most part. Although I would actually throw out this last one as you would know that starting with a C, you would put the C in the middle, not on the outside. But we can use this to kind of indicate why this last one is not okay as well. So with these possible Lewis structures, we're showing the assigned formal charges, and this would be, good practice to go through and see that you could come up with these here and these here and these here. So comparing the structure, this one has 3 zeros. This one has a +1, a 0, and a -1. So this would be a preferable structure to this one because it minimizes the formal charges. This one appears to be the worst because you don't, you have, not just do you not have all zeros, but you have +2s and -2s as compared to +1s and -1s. So this first structure is preferable because it is a structure that has basically all zeros instead of having anything other than that. So that's how we can make that kind of decision. Another example here. Again, we're looking at one that does have a charge, and we're looking at a couple of possible structures. The first one has -1 in one location. Here we have a -2 and a +1, so a little bit more there in terms of where they're located. Here we have a -2, a +2, and a -1. So it looks like probably the one we want is this first one. The difference here is, as you can see, is which is the central atom. And, if we're writing it like, if we're writing it, I guess we're not showing, I guess this one would be the one that shows the central atom correctly in terms of the way it ends up. But there will be cases when you maybe you don't see it in that way, and you would need formal charge to figure that out. Some additional examples here, so please look at those as well. And then we'll go ahead and stop here and talk about resonance in the next video.